You ever stop and think about the invisible forces that are, holding our modern world together? I'm talking about the power behind those giant construction machines, the sleek airplanes soaring overhead, and even the simplest tools in a hospital. Well, believe it or not, there's a single principle discovered almost 400 years ago that makes it all tick. Today, we're pulling back the curtain on that hidden force, Pascal's law. So let's just start with this, because it's wild when you think about it. How can your foot, with just a little bit of pressure, stop a 2-ton car dead in its tracks? I mean, it feels impossible, right? Like some kind of magic trick? But what if I told you it's not magic at all? Nope, not magic. The answer is pure, brilliant physics. It's a secret that lets us multiply force in ways our muscles could only dream of. And trust me, the car brake thing, that's just the tip of the iceberg. This incredible power is hiding in plain sight, pretty much everywhere you look. This hidden force is the silent workhorse of our world. It's what lets a single excavator scoop up tons of dirt. It's the precision behind a surgeon's most delicate tools. And yeah, it's the strength that lets you lift a whole car off the ground with a simple little jack. This one principle has quietly but powerfully built the world we live in today. So how in the world does this work? To really get it, to solve this mystery, we have to understand the powerful principle at the heart of it all. And for that, we've got to jump in a time machine and head back to 17th century France to meet a true genius. His name was Blaise Pascal. And this guy wasn't just a brilliant mathematician. He was interested in everything. And sometime in the mid-1600s, while he was just messing around with fluids, he stumbled upon a revolutionary idea that would completely change engineering forever. He came up with what we now call Pascal's law. Okay, I know. That definition looks a little dense, a little textbooky, but the actual idea behind it is so simple. Here it is in a nutshell. Pressure applied to an enclosed fluid is transmitted equally throughout the fluid. That's it. Think about a simple plastic water bottle. When you squeeze it, the pressure you're putting on it with your hand isn't just felt right where your fingers are, right? No, it's instantly felt everywhere inside that bottle. And that simple, kinda obvious observation, well, that's the key to everything. And here's where it gets really powerful. That observation unlocks a secret weapon, and it's this super simple formula. Pressure equals force divided by area. Pascal realized, hey, if the pressure is the same everywhere in the fluid, then I can play around with the area to totally change the force. And that, right there, is how the magic of force multiplication is born. So here's the game plan. It's a simple 3-step process. Step 1, you apply just a little bit of force to a small area. Think of pushing a tiny piston. Step 2, that creates pressure that, thanks to Pascal, instantly spreads out evenly through the whole fluid. And then, step 3, this is the payoff. That same pressure pushes on a much bigger area, like a wide piston, and generates a huge amount of force on the other side. A tiny push-in results in a massive lift-out. It's genius. Now, Pascal himself proved this in the most dramatic way possible. He took a big, sturdy wooden barrel, sealed it up, and stuck a super long, skinny tube into the top. Then he just started pouring a little bit of water into that tall tube. The weight of that tiny column of water created an insane amount of pressure at the bottom, which then spread all through the barrel. And boom, the barrel burst. A tiny force, a spectacular result. This one discovery basically gave birth to the whole field of hydraulics, using fluid to transmit power, and it has totally transformed our world. So let's take a look at how this ridiculously simple principle is powering the tech we use every single day. Okay, let's go back to our car. When you step on the brake pedal, you're pushing a small piston. That creates pressure in your brake fluid, which travels down the lines to much bigger pistons at your wheels. Those bigger pistons then clamp down on the brake pads with incredible force, stopping your car. Simple as that. It is the exact same idea with a hydraulic jack. You make these small, easy pumps on the handle, right? Each pump applies force to a little piston, building up pressure in the oil that then acts on a big piston, which effortlessly lifts thousands of pounds. And once you know what to look for, you see this power everywhere. It's moving the mighty arms of bulldozers. It's safely deploying airplane landing gear. It's shaping solid metal in giant factory presses. Heck, it's even at work in a simple medical syringe, where your gentle push delivers medicine with perfectly even pressure. So why does this work so well with liquids, like oil or water, and not with, say, air? Well, the key is that liquids are basically incompressible. You can't really squeeze them down into a smaller space. So they transfer that pressure perfectly. Gases, on the other hand, are super compressible. If you tried to do this with air, all your effort would just go into squishing the air itself, not actually moving anything. So, you see, this is way more than just a history lesson. Pascal's discovery is just as crucial today as it was centuries ago. And get this, it's still shaping our future. Just let that sink in for a second. For nearly 400 years, this one beautifully simple principle has been a cornerstone of engineering. It just goes to show you that the most powerful ideas aren't always the most complicated ones. They're the ones that are timeless. And its story is far from over. Engineers are pushing hydraulics into some unbelievable new places. We're talking advanced robotics, high-tech prosthetic limbs that give people new freedom, and even in the massive, powerful systems that control rockets blasting into space. I mean, the same idea that burst Pascal's little barrel might one day help us build the first cities on Mars. How cool is that? So, from a simple observation about a bottle of water, Pascal's law gave us a new kind of superpower, letting us literally build the modern world. And it just leaves you wondering, doesn't it? What new worlds will it help us build next?